lesson is lesson 84, identifying quadratic functions. What is a quadratic function? And what is a function, period? Remember, when we are dealing with this right here, f of x, this is called function notation. This f of x can also be seen as just a plain old y. But when we're talking about function notation, that's where you see that f of x. Your quadratic function is always going to have three terms. Actually, sometimes it can only have one term. The most important identifying characteristic of the quadratic formula is this x squared term here. Sometimes we'll see a quadratic function with just that piece. As long as it's got that little 2 right there, it's exponent of 2, then it is a quadratic function. Can't be any bigger than a 2. Can't be a 3 or a 4. The biggest exponent has to be a 2. This part is the quadratic part. This part is your linear part. It's linear because if I remove this term right here, I'm back to y equals mx plus b, which is linear. The last part, the c, is called the constant term. In other words, if I remove both of those first two terms, I'm just going to have a constant. A constant is just a dot on a number line. So there's my linear, and then when I have that exponent of 2, I am now in the quadratic function area. That's how you can identify it. If you're given something that you cannot write in this form, then it is not a quadratic formula. A quadratic function. This is called the standard form. You should always try to put your quadratic formula in standard form. This is actually a parabola. We'll learn about what a parabola is in just a moment and how it is sketched. Let's take a look at a first example and see if it is a quadratic function. Of course, they're not going to give you anything so simple as this. They're going to give you something that looks like this. Y minus 15x squared equals 3 plus 2x, where I have to put y by itself. Putting y by itself means I'm going to take this negative 15x and move it over and make it a positive 15x squared. Positive 15x squared. What you do to one side, you have to do to the other. Over here, those are going to cancel on the other side of the equal sign, making sure my leading coefficient is the one that has the x squared. So this is written first. The second term is always the one that has the x. And the last one is always the constant. Since I have a squared term, a term that has an invisible exponent of 1, and a term that does not have a variable attached, it is a quadratic function. Let's take a look at one more. Y minus 62 equals 3 minus 2x. Right away, I don't see any exponent of 2. So at first glance, I'll say no. But let's solve for y and take it to its conclusion. Adding 62 to both sides, I get y equals, making sure you put your x term first, and then that equals plus 65. And again, there is no x squared term, therefore this is not a quadratic function. One more. Let's look at 9x to the 4th power minus 9 equals y plus 8x. This time the y is on this side of the equal sign, which means I'm going to take my 8x and move it over to the other side. Minus 8x is how that's done. Minus 8x, what you do to one side, you have to do to the other. And I get y is equal to 9x to the 4th power minus 8x minus 9. See this 4 here? Remember, that cannot be anything bigger than a 2. since this has an exponent of 4? The answer is no. That is not a quadratic function. This first term right here, this a, that is going to tell you which direction your parabola is going to go. Your parabola on your xy coordinate system, the standard parent graph of a parabola always sits at the origin and then kind of opens up this way and opens up this way. Okay, that's the parent graph of the parabola. If this a is positive, then it's going to go up. And if that a is negative, then the parabola is going to open down. Pretty soon we're going to learn how to graph the parabola in different parts of our xy coordinate system. We'll save that for another lesson. Today's main goal is to understand what a quadratic function looks like and to be able to identify it and to kind of sketch a parabola. Sketching a parabola just asks us to make a t-chart. So let's take a look at a sketched parabola and see what it looks like. First, let's get an xy coordinate system sketched. So if you could sketch an xy coordinate system while I clean up the board.